Let's look at some mechanical design. This is a question. A question exercise or a problem. So let me go straight to the question and deal with it. Yeah. So this is a question that was explained the summary, so I need to do it step by step. So step by step first. Let me say this is a rotational frequency. A pinion of a cast iron is rotating at the frequency of this. Then it has teeth of this, and then the pressure angle, and then the phase width, and then the static stress. So they say calculate the PCD of the pinion. So to calculate the PCD, number A, the equation of a PCD is stand for what? Pitch circle diameter, which is the diameter of the diameter of a gear. So the PCD, the equation of PCD is this: M represent the module, then the teeth. So multiplying this together will give you a PCD. So what is our module? The module, it's 6 millimeter. So you put 6 millimeter, converting the 6 millimeter, you divide it by 1,000, because M represents 1,000 is the same as 6 times 10. The M represents the negative 10 to the negative 3. So you can say, changing to millimeters, can change the M to 10 to the negative 3, and then multiply by teeth. We have 13 teeth, so let's say 13, what 13, 15. Then multiplying this together, what do we get? And multiply this together, let's just say quickly drop down. Okay, this is so it's 6 negative 3 multiplied by 15, which is this is 0.09. 0.09 watt meter, or you can leave it like this as 6 millimeters. You don't change the millimeter because it's, when you multiply like this, you'll get 90, and then you didn't change the millimeter, it becomes like this. So there are many ways to do this. Depends whether you want to use it in meters or you want to use it in millimeters. So now, because it's millimeters, you just leave it to millimeters. Okay. The outside diameter of the gear blank, the outside diameter of the gear blank. So to calculate the outside diameter of the gear blank, use the formula is there, which says PCD plus 2 times modulus, which is 90 plus 2 times 6, which is calculating this on you, say 90 plus 2 times 6, which is equals to 102. So we have 102. I didn't change the module to millimeter, so I don't change anything, so it's simpler that way. Number C, what it says calculate the depth of a cut. So the depth of the cut is the deepness of the teeth. The depth cut, you just say depth, which is equals to 2,25 millimeter, not millimeter, it's module, so it's 2,25 and then multiply by 6, which is the module. So when you're calculating this one, you'll have something like, what is it? It's like 2,25 multiply by 6, and then equals 13,5 or 13,56. So you have write 13,5 millimeter, and then it's the answer. And the next one, it will be number D. The question says the speed in meters per second. So the equation of a speed is V equals to pi multiplied by V. Not V, it's PCD, because we are dealing with PCD. V, it's a mistake. PCD multiplied by rotational speed, all divided by 60, and then you'll have pi multiplied by PCD. Or PCD is 109 versus 90. Then here you can convert, because a speed you have to be in meter per second, not in millimeter. So in converting this one, the 90, because you know that millimeter, it's 10 to the negative 3. You can just write 10 to the negative 3, and then say multiply by the rotational frequency, which is n. This is the rotational frequency rev per minute, so which is 600 divided by 60. And then putting on a calculator, you'll have something like pi, shift pi, multiply by 90 to the negative 3, multiply by 600, then divide by 60. Then you'll have 2,83, let's say 2,83 or 2,27, 2,827. Okay, writing 2,827 8783. Oh, it's 2,83 meter per second. So and then this is second. Okay, and then the next question, what does it says? It says the velocity. Okay, the form factor, which is y, the involution. Okay, so the form factor, we'll say we have the okay, the equation of a form factor is this one, minus little brackets. So there's a video explaining this one, so that's why I'm moving quickly. So if I put them together, it will be long. So short video, it helped to understand. So just explaining everything. So you have something like this at the moment. So yeah, you're calculating a form factor. So 0,912, and then here the t represents the tooth of a pinion which has 15 teeth. It has 15 teeth. There's 15 teeth on the pinion. So you have to multiply this together. Multiplying this together, what is it? 0,15 this side. So you'd say 0,154 minus 0,912 divided by 15. What is it? 0,932. So the value of y is 0,0932. See, yeah. Okay. From this point, you go to calculate the velocity factor. So the velocity factor, they are different. Velocity factor depends on the velocity that you got from this top. So you have to check the velocity before you pick the formula, because there are different kind of velocity factor. So this is a velocity factor. I'm using C. C is the speed of light, so this one is not the speed of light. So because from the top you got 2,83, you use this V. This V represents the speed that you got it from there. It's 2,83, and then calculating this one, you have calculating, I'll say, what is it, 3 divided by what, let me say close brackets or bracket, it's 2,83 brackets, and then the answer, I say answer, the answer is 0,5 0,514, and then 0,5. So it's 0,515. And this is a factor. A factor does not have units. When I remember it's like that, but I don't know now what factor. Okay, this is a working stress. Now, from the velocity you're going to the working stress. Working stress is a stress that causes that pushes the gear. So how do you know it is pushing the gear? Okay, this is a stress that causes the gear to move. Let me try to draw, maybe it will be possible. If you have two teeth like this, so this tear from the other gear is a gear, this is it's a gear, don't know, is other teeth. It will experience a stress in this area to push this gear, this area here. So it's a working stress to work. So how do you calculate the working stress? A working stress, because here we have already calculated the velocity factor. So working stress, working, and then multiply by the static stress. And then this is a velocity factor because it moves this velocity. This is a basic stress or static stress, what you call it, static stress. We use this stress to calculate the working stress and the velocity factor. So this tells okay, multiply by 10 to the 6, and then what is the velocity factor is 0.515. Calculating 0.515, and then we'll have multiplying this together. So if you don't understand some of the things I have explained to other videos, so you check the video or below. It's similar to this one. I was just explaining some of the things. Maybe it will be helpful, maybe it won't be, but to understand it takes time, big time. Understand. So if it was easy, everyone will do it. So this is the stress. You see, it's 61, how many zeros? 3 plus 60, how many? It's 1000 0, another 1000 0. So it's like 1000 and 1000. So it's 61,8. Let's say times 10 to the 6 Pascal. So a stress as a unit is Pascal. So because this one is time to the power 6 is to be 6. But if you can convert this by a calculator, you'll see that is a megapascal, because I counted the 0 from the back like this. You see there's 1 0, so the comma it's here, so it's 6000, and then there's a comma before that. So from there you move the comma once, you say 1 0, then 2 0, you move the comma, 3 0, 4 0, 5 0, and then 6 0. So where there's instead here the power, you'll put 6 because you have moved the comma 6 times. So you stop here between where I have stopped. This is how it's simplified. If you don't ever calculate sometimes. So from this point, each one is preferable. Okay, I'm trying to make it simple. Okay, from there let's check the next question. What does it say? So to calculate the tangential force, a tangent is something that touches the circle at one point. So a tangential force, that means the force is acting at some point in a circle. So normally the tangential force act here. So because it's acting on on the PCD. So we're looking at the force that act on the PCD here. So the force that touches here, when it moves, so to move there must be a force that touch the gear here to rotate, because the gear is like something with teeth like this, and then to move it needs another gear or something round. It's not like this. I'm writing quickly. So it will push somewhere here. So to push here, it touches the circumference. So the circumference, I mean the PCD, is the same as circumference. So it touches the point here and then it moves this. So because of the distance from here to here, it's a radius. So we can, okay, I'm talking about torque corner. So the force in that act here is a tangential because it acts at the circle. So a tangential, they are talking about something that acts on the circle. It touches at the single point in a circle. So the circle here, they are talking about the PCD, which is the pitch circle diameter. So the tangential force, it's which is it is H. Okay. So we'll have something like tangential force. We'll have to use the tangential force, the Lewis formula, which talks about what, the pi, they multiply by the m, multiply by the factor for, and then multiply by b, and then multiply by the stress. So when you check at this equation, it's like it's the similar to the one force over area. So the stress, the equation of a stress is like this. So this is like somewhere there's an error. So this point from here to here, the equation of circumference. And remember, so this might be a little smaller radius from the what you call, from the PCD. It's a smaller radius, like if you have something like that, and then from the point from here to here, it's a radius, right? From here to this point, it's a radius. So this is a PCD. So the modulus is this point from here to here, to the outermost part of the teeth. So it's like this. So this point here, it shows that it's a little bit of an area. Maybe it can be a length, and then this one is a face, is the other side of. You can check on the textbook. A faith width is the side, the other side. So it creates an area like this, something like this. So this one, it's a factor. So a factor, it can be like how big how big the gear touches. The gear can touch this area and this area, but it will be reduced by the factor. So the factor is like a ratio or something like that. So I think there's an area here. So B times this one is like area. Like this one itself, it's an area. It's a length, this one. And then the B is can be a breadth, can be. So, and then multiply by the factor. The factor tells us the size, the error, or how did they reduce it. So the force that acted at this area, so it's called, it can be a stress. So calculating this, the tangential force, well, you have to say pi multiplied by m. M is a module. So a module, which is 6 Can we convert? Yes, we have to convert because you have to leave it to. So you can say 6 times 10 because a millimeter is a -3. So if you don't remember to convert, how to convert a millimeter is a -3, and then the face width, this is B, the face width, which is 50. Yes, it's 50. So you're converting the 50. So like I've said, if you don't remember how to convert, you can change the M to a -3. It's another way of converting. So you have here this, and then you have the factor which is 0.515, and then here is it a working stress or a stress? According to that, it's a working stress. You see, it's 61.8 megapascals, and then the factor is 0.4. This is the factor is 0.0935. So it's not this one. Is 0.932. So multiply by the working stress is 61 times 10 to the 6. So others, they even put everything here like this. They put the static stress. If you didn't calculate the static stress, multiply by V here at this position. Instead of calculating this, they put this one in and they substitute everything. So instead of putting a working stress, this, so it might seem sometimes confusing. So you must be so calculating this whole. Let me just punch it out, show it later. Okay, multiply by the answer, and then say shift, and then this is pi. Say shift and then pi, multiply by 0, 0, what? No, is 6 exponent -3, multiply by the faith bit, it is 50 exponent -3, multiply by the working stress, which is 61.8 exponent 6, then multiply by what's missing? Oh, the stress is already there because it's the answer. Go 1, 2, 3, then the factor is 0.0932. I think it's completely, it is done. So it's the force 5428. 5428, comma 45 in Newton, because the force is in Newton. Then let's look at another question. The torque. So the torque is the one that I wanted to try to explain about the radius things. So the radius is from the center to the circumference. So this is number H, this is number I. So a torque, it's tangential force multiplied by PCD divided by 2. So PCD is the diameter, so radius is divided by 2. So calculating this, you'll have something like 5428,45 multiplied by the PCD, which is 90. Let's say 9 is 90 times 10 to the power negative 3, because it's in millimeter. So the M represent millimeter. I think it's already say calculating this one. You have something like, what do you have? Not this one, not this one. You have something like 5428, 45 multiplied by 90 exponent negative 3 divided by 2. So the what do you call it? The torque. This is the torque one. Then what's the next question? So this one is like the shaft diameter. The shaft diameter. What is the shaft diameter? Diameter of the shaft. That's what's the shaft diameter. So after I what is it is J. So calculating the shaft diameter, you have to know. You have to be have the what do you call it? Shear stress. A shear stress. A shear stress. So changing this one to be equation of the formula, we have something like D square root cube root, and then you have something like T multiplied by 16 divided by shear stress multiplied by pi. So you can derive this equation, or you can direct substitute from here, and then we'll do the other things. So looking at this in the table, what is the value of a shear stress of a cast iron? I'm not sure, but let me assume it's 36 megapascal shear stress. So it's already done that page. So I have something like this, and then this one is 244. The space is finished, and then multiplying by 16 dividing by multiply by pi. So calculating this one, what do we get? We get something like 0.033, I think 332. So it's in meters. So converting this one in millimeter, you just say 1, 2, 3. No, I have to start from the to understand. You move this comma 1 2 3, so it will be this. Because you are moving backwards, it will be negative. When you move forward, it's positive. So what is this? It's millimeter. So this is the answer of the diameter they are looking for. That's 8.